Good afternoon to Puan Nohana and my lovely friends. Today, our Group ONG, will be present about the solutions of study case number 1. Our group teammates are Justin, and that's me, Pian Shin, and Ng Qian Hui. And we start from the introduction. So first, integration is reverse of differentiation. It is the process of obtaining a function, we say y, from a dy dx. The integration is used to add small and discrete data which cannot be added singularly and represented in a single value. Besides, integration can be used to find area or even volumes like study case given. Integration is very important to a civil engineering students like us, and is used to solve the calculations of mechanics, constructions, and so on. The function to be integrated is known as integral. The integration of a function which already be differentiated with respect to dx is denoted by the formula given, shown by the slide. So integrate the function dx will be equals to the function plus c, and c are the arbitrary constant. Integration is applied in our study case, which require us to find the area and the surface area of the land. So before we proceed to the final table, we'll simply go through the questions. A farmer who wishing to purchase this land would want to know exactly how large an area. Based on the ground plan, the land is bounded by the x-axis on south, the x equal to 100 in the west, the lake described by the function y equals to bracket square root 2 times x per 10 bracket power 2 plus 60 minus x in the north, and the line x equals to 1000 in the east. As an owner of the land, you decide to do an earlier calculations so that the sale and purchase process will be fast and smooth. You start by sketching the graph and finding the area and the land. Then you also want to find the surface area of the land. Next, we proceed to the final table. So, facts. Number 1, a farmer wants to purchase a land. Number 2, the farmer wants to know how large the area of the land is. Number 3, the land is bounded by the x-axis on the south and the x equals to 100 on the west. Number 4, there's a lake described by the function y equals to bracket square root 2 times x per 10 bracket power 2 plus 60 minus x in the north, and the line x equals to 1000 in the east. Number 5, the owner of the land. You decided to do an earlier calculation so that the sale and purchase process will be fast and smooth. Number 6, as the owner of the land, you want to find the area and the surface area of the land. Next, idea. Number 1, the land has a curved sides as the lake described by a quadratic function. So the land is not a square, rectangle, or a polygon. So number 2, after sketching the graph, the lake will located above and right of the land, as it is north and the east of the land. The sale and purchase process will be fast and smooth after the owner, that's you, do the calculation. Number 4, the area of the land is in 2 dimensions, while the surface area of the land is calculated in 3 dimensions. Number 5, application of integration is used to solve the problems. Exactly. So, learning issue. Number 1, what is the shape of the land? Can you imagine it? Number 2, what is the location of the land? Is it right, left, up, or low? Number 3, why must the owner of the land calculate the area of the land and the surface of the land? Why? Number 4, why must the owner of the land sketch the graph? Number 5, what is the difference between the area of the land and the surface area of the land? Number 6, what knowledge is applied to solve the study case or the question? Number 7, why is the application of integration is used to solve the problems? So, action plan, resources needed. First, prepare a graph paper of using a software to draw down the graph of the land. Number 2, find the related data and information by using internet. Find related data and information using notes given by the lecturer or the reference books, and so on. And that's all from me, and I will pass to Eng. Hope you enjoy and learn something from our presentation. Thank you.
Hi, I'm Eng Qian Hui. So I will now continue our group presentation with the problem background. As you can see on the slide, a farmer who wishing to purchase this land would want to know exactly how large an area. So based on the ground plan, the land is bounded by x-axis on south, the x equal to 100 in the west, the leg described by the function y equal to square root of 2 times with x over 10, close bracket, square plus 60 minus with x in the north, and the line x equal to 1000 in the east. So from these questions, we get all the important information for us to solve this case study, which is, first, we know the land is bounded by x-axis on south, and the x equal to 100 in the west. The leg described by the function y equal to square root of 2 times with x over 10, close bracket square, plus 60 minus with x in the north. Lastly, the line x equal to 1000 in the east. So from this sentence, we get to know where the land is exactly located. So now I will continue with the questions. As an owner of the land, you decide to do an early calculation so that the sale and purchase process will be fast and smooth. So you will start by sketching a graph and finding the area of the land. Then you also want to find the surface area of the land. From these sentences, we get to know the question requirements are, first, for us to sketch a graph, and then we need to find the area of land. Lastly, to find the surface area of land. So, the knowledge of Chapter 6, Applications of Integrations, is applied in this case study for us to solve the problem. Besides, we were given an identity, which is as the owner of the land. So, as the owner of the land, we ought to know the area of our land so that we can determine the selling price of our land. Because area of land is significant in determining the selling price of the land. So that's all for problem background. Later, I will continue with the solution of case study. So for the solution of case study, first, we know that we have a function here, which is y equal to open bracket square root of 2 times with x over 10 close bracket square plus 60 minus with x. And as you can see, this is a quadratic equation. But first, we need to square all the numbers inside the bracket. So we will get 2 over 100 x squared plus 60 minus with x. And 2 over 100 can be simplified into 1 over 50. So lastly, the equations for the functions will be in the simplified form, which is y equal to x squared over 50 minus with x plus 60. So this is the simplified form of the equation. After we get the simplified form of the function, we need to now identify the curve upwards or downwards. So we know that in these functions, the a is 1 over 50. As you can see here, a is 1 over 50. So a is bigger than 0. So the curve must be a smiling curve, which is curve upwards. Next, we need to find the vertex. To find the vertex, we need to use the formula x equal to negative b over 2a. Okay, so the b is negative 1 and A is 1 over 50. So x equal to negative, open bracket, negative 1 over 2 times with 1 over 50. We will get lastly x is 25. To get the y coordinate, we just need to substitute x into the function 25 square over 50 minus with 25 plus 60. Lastly, we will get 47.5. So after we got the vertex, we can now sketch the graph. Vertex somewhere here, x equal to 25 and y equal to 47.5. After we get a vertex, we draw the curve, smiling curve, and then the two lines given, which is x equal to 100 and x equal to 1000. And lastly, you can see that there is a shaded region under here. Shaded region. So this region is the area of our land which we want to find. So that's all from me. Thank you.
Hi, my name is Tian Xin. So after we sketch the graph, we'll continue our solution to find the area and the surface area of the land. So to find the area of the land, first we need to implement the formula, which is area equal to integrate fx minus gx between the limits of a to b. So fx is the upper function and gx is lower function. So our upper function will be x squared over 50 minus x plus 60, and gx will be y equal to 0. So our a will be 100 and b will be 1000. So after we solve the equation, we will get the final answer for the area of the land. Find the surface area of the land, so we need to implement the formula. So first we need to differentiate the function. We will get 1 over 25x minus 1. So we will get a new equation. For the integration part, we will use Simpson rules. So the increment of x, which is h, will be 50 to get a more accurate answer, and the increment we will get 18. So this column we will divide into 3. The first column is when x equal to 100 and 1000, and the second column which is when the iteration is in odd number, and the third column is when the iteration is in even number. So if we simplify the formula, we will get h over 3 times u plus 4v plus 2w. So the u is the total of when x equal to 100 and 1000, and the v is the second column, and w is the third column. So this will be the result we get from the Simpson rules, and we continue substitute it into the original equation, which is it need to times to 2 pi, and this is the final answer for the surface area of the land. As a conclusion, we have applied the knowledge that we learned from Chapter 5 Integration and Chapter 6 Application of Integration. The equation involves two formulas, which is the area and the surface area of a bounded region, and Simpson rules was used to solve the equation for the surface area of the land. That's all from us. Thank you.
Duh.